Hi, I'm Ed Sperling. I'm the editor-in-chief of System Level Design. I'm here with Naveed Sherwani, the president and CEO of Open Silicon. Naveed, we've heard a lot about 2.5D. Where are we now?
I can speak about 2.5D in the world of ASICs. In the world of ASICs, our NREs, just for doing the back end mask package test, the whole ASIC part of it was in the range of about $3 to $5 million a few years ago. With the technology moving to 28 and then to 22 and then to 14, IP budgets going from 2 million to 8 to $12 million. Now the same back end, I'm not including the front end, the verification piece of it, is now going into 12, 14, $20 million. At this level of NRE investment, there are very few companies which are willing to start new projects, and those projects must have very large market segments that they address to justify the investment and have enough ROI. So I believe that unless we have a breakthrough technology which will allow lower NREs, innovation will stop. 2.5D is a very logical solution to the NRE in ASICs, and also addresses the other issue where we are looking for medium to small volume chips and not for very high volume chips. But then in addition to NRE, there are some other advantages of 2.5D which conventional ASICs do not provide. And one being that on the interposer, we can not just take chips from a single generation, we can take chips from multiple generations, we can even put photonic chips, we can put all kind of different chips made in different process technologies, integrate them on the interposer, and have the entire system being built on the interposer, which still runs at VLSI speeds as compared to PCB speeds. So this really not only provides a very comprehensive solution to the NRE and the part price and the overall total ownership cost, but also provides new capabilities that we cannot do today.
You know, one of the things about 3D is that there's been a lot of supply chain issues, particularly around known good die. Does 2.5D get rid of those issues, or is it still an issue there?
It's still an issue there. I think known good die is an issue that as an industry we will have to solve. Because if we are going to graduate from 2D in any direction, any which way, where we have to reduce the size and we have to improve the performance of the system, we'll have to get rid of the package. If we have to get rid of the individual packages, then we'll have to figure out how to go around the known good die problem. I believe in the last few years, a lot of strides have been made in this direction. I think we still need a lot more innovation, a lot more industry standards and collaboration between different partners, but we are well on our way. And I believe that I can see that we will be able to solve this problem in a very near future. So I'm very optimistic that the engineering talent that we have in our industry will overcome this, and this will not be a major obstacle to 2.5D deployment.
Where did we hit the wall that says, okay, it's time to go vertical with chips as opposed to continue on a planar path?
I think if you look at different industries, they have different needs. If you look at networking boards, they're huge and they consume a lot of power. So as 10 years ago, we were assuming the largest data centers we were assuming would maybe a size of 1/4 of a football field. Today, we have data centers which exceed football fields, consume multiple megawatts of energy. They are huge. So we can imagine today that the data centers of the future will be much bigger than that. So what will bring down the size, power, improve the performance, reduce the environmental impact is important. So if you continue to build a 2D boards for such huge data centers, you're not likely to meet those goals that I just stated. So I think the only logical direction is the third dimension. And I think since 3D is a bit away, 2.5D is the first logical step that we take in that direction.
What markets do you see 2.5D playing in? You mentioned the data center. Is the data center the first one because it's more cost resilient, or will it happen in a lot of places?
I think it will probably start with data center, compute infrastructure, and those high cost chips where the performance power is somewhat more important than the cost. Because as the technology would be in smaller volume, interposer cost will be higher. As a result, this will start out at low volume, high cost ASICs, and then it will proliferate from there. But I think in about 2 to 3 years, you should start seeing applications in the area of consumer, probably in the high-end equipment first, and then or everyday consumer equipment after that. So we are definitely thinking of a roadmap between 3 to 5 years.
One of the things about 2.5D is that it's also, while we think about it in terms of we don't have to rewrite analog IP for the latest node, it's also a way of really improving performance and reducing power.
Yeah, I think there's a huge performance improvement because you can do each chip in the appropriate technology. And I mean, you can do a chip in 28 nanometers because it has a processor and needs to run at high speed. You could do a piece of I/O which doesn't need to run at a very high speed and 65 nanometer CMOS. You can do something in gallium arsenide. You can do something in SOI. So you could build different chips with the more appropriate technology and then integrate them on the interposer. So having to build and port everything onto the single die had pushed us to really make analog mimic technologies that it doesn't need to, because we didn't have the liberty, we didn't have the freedom to use different process technologies and still build the same chip unless we go to a PCB. Now we have that freedom. That will allow us to build multiple dies in multiple different processes and then integrate them on an interposer to build the 2.5D chip.
One of the complaints about stacked die has been cost, but when you think about where the costs are these days, they're no longer just in the silicon, right? It's now in the design, it's in the manufacturing side of things. It's not as simple an equation as what it was before.
That is true, and I think it is more true in ASICs than it is true in the ASSPs and high volume markets. I think in ASICs, the NRE was smaller, and then the total ownership of the parts was much larger. As the NRE is growing larger and larger and the segments are splitting, the total cost of ownership percentage as commanded by the NREs become higher. So you're absolutely right. So in order to understand the total cost of ownership, we have to take into account the total NRE plus the part volume multiplied by the price. And that's how we can determine the ROI for a particular customer.
One of the advantages of a stacked die is that it really starts taking advantage of a platform strategy and a more complete subsystem strategy. Where are we now with that kind of stuff? Are we starting to see platforms? Are we starting to see them being used effectively, or are we still a couple years away?
Well, I mean, if you look at FPGAs, they have taken a path where they have essentially the new FPGAs have taken the stride. They're 2.5D. They're composing various different dies onto the same interposer. You can think of that as a platform because they have a capability of interchanging those dies and bring to the market a different kind of performance, power, different combination of IOs, different processors if they want to. So I think, not to talk specifically about open silicon, we have also taped out a similar device where on an interposer you can have a choice of processor, IOs and things like that, and combine them on the interposer to build a system fairly quickly without it having to wait for the ASIC-like timelines. So I think absolutely strides are being made in that direction, and I expect to see in the next 6 months to a year a lot more announcements from various different companies in that direction.
We've been talking about derivatives for a long time. Are we starting to get to the point now where derivatives really are simple, or are they just so hard that we have to change our strategy?
So I think derivatives are definitely taking off. I think the biggest issue I think we see with derivatives now is the NRE. So what previously was an issue of cost in terms of availability of manpower and things of the sort, I think it's more becoming what is the cost of a derivative. So in the marketplace in the last 9 months or so, this has the bigger complaint of my customers than the lack of resources that they needed to get the derivative done.
Is the supply chain mature enough to handle that?
I believe so. I think one of the things I think in the semiconductor industry, which is really mature, and at least I would say in the last 20 years or so, I have not had major complaints. Now, we have hiccups, we have supply issues, but if I look at challenges in design, I look challenges elsewhere in IP and so on and so forth, I would say supply chain is not the top issue in my mind. I think they have the entire supply chain partner, the foundries, the package, the test, and the logistics have done actually very well, I would say, in the last 10 years as compared to design, as compared to manufacturing equipment, as compared to process ramps, as compared to IP maturity and delivery. So all of those areas in semiconductor industry have had more challenges than the supply chain and wafer package and test.
We've heard a lot about putting this in perspective, we also heard a lot about the hybrid memory cube and 3D memory. Where is that now?
This is an excellent question. Just like I'm very excited about 2.5D, I am very excited about 3D because I am a big believer that the only direction to go now in ICs is up, right? So while I consider 2.5D is a very logical step that we must take, the ultimate direction is 3D, fully integrated, complete systems built in layers on top of each other. And as you know that Open Silicon has been a founding member of the HMC Hybrid Memory Cube Consortium from the very beginning. And we have committed ourselves to making sure that at least our part, which is the controller technology, is available for the Hybrid Memory Cube. Hybrid Memory Cube, I think, is going to become a very commonly used memory 2 years from now, as both Micron and Samsung plan to release them later this year, early next year. And I think, again, as I said with 2.5D, the initial users will be networking, compute infrastructure, compute server type of chips, where we can accommodate or sustain higher cost of such memories. But I think, given the size of the memory and the fact that such a huge memory is so close to the processor, I believe that will completely change the way we think of processor memory architecture. I actually have said in my recent speeches that I believe that the computer architecture books might have to be rewritten, because computer architecture from the day of its beginning has always thought about a processor, a memory, and a thin pipe. Well, if there is no thin pipe, if a very large memory sits very very close to processor, how does the processing happen then? What does the process elements look like? How would you design an architecture? So I think those are very open questions, and that's why I have in the HMC consortium pushed for that we should get top 10, 15, 20 universities who are working on computer architecture involved in that, because I am very hopeful that the professors will look at this architecture and then say, aha, now we can do things that we could not even imagine with the distant and thin memory model that we have had from the beginning of computer architecture.
Naveed Sherwani, thank you very much for your time.
Thank you.